They didn't just train an AI on internet data, they built an entire society from scratch, using the minds of 1,000 real people, with real memories, real values, and real goals. Then they hit play and watched what happened. One agent lied, another one rebelled, some tried to form governments, others just wanted to go home. This isn't a game, it's the start of something else. Not a simulation of a town, but a simulation of us.
The universe is deterministic. It's godless and neutral and defined only by physical laws. The marble rolls because it was pushed. The man eats because he's hungry. An effect is always the result of a prior cause. We fall into an illusion of free will. Our feelings, our opinions, judgments, decisions. Then those decisions can only have been the result of something prior.
It all began with a now famous study called Generative Agents, Interactive Simulacra of Human Behavior, authored by Jun-Sung Park and Michael Bernstein from Stanford, Google, and openai. And in this research, 25 generative agents were placed in a pixelated town. Each had memory, reflection, and planning capability, but they weren't just reciting dialogue, they were living. But now they've gone from 25 agents to over 1,000. From toy environments to full-blown simulations of voting, crime, law enforcement, manipulation, and power. These aren't just bots walking in a loop. They're learning to deceive, persuade, and form alliances based on real human data. The research evolved further in generative agent simulations of 1,000 people, led again by Jun-Sung Park with Carol and Joe, and we've moved from micro-simulation to something at societal scale. The research introduced human likenesses to simulations by giving agents psychological profiles based on 1,000 real people, drawn from interviews, behavior logs, and survey data. This is more than fine-tuning. These models weren't just predicting words, they were simulating people, their values, fears, political identities, and coping strategies.
Allows us to better understand how society's values and views and opinions have changed over time. We ask a whole variety of questions, everything from their perspectives and interests and information related to race relations to spending patterns.
The GSS provides the sociology of things. In the social science, we have the GSS. Nowadays, data science allows people to more easily predict behavior.
One agent flagged another as dangerous, another tried to start a protest, some were paranoid, and others were deeply empathetic. And the models, they didn't just reflect us, they mimicked us with bias, with emotion, with intent. This wasn't just a simulation of personality, it was a simulation of human lived experience. In 2025, a team led by Jinghua Piao and Yu-Wei Yan released Agent Society, a massive simulation scaling to 10,000 agents and millions of interactions. At the same time, on the limits of agency, it introduced a scalable framework for running 1,000 agents on a single GPU. Through innovations like memory pruning, local context windows, and event-based rollouts, the team achieved massive agent population simulations without crippling compute costs. In their experiment, 1,052 agents lived inside a virtual world with schools, police stations, hospitals, churches, and private homes. Agents could organize parades, elections, and protests. They remembered who spoke to who, and what was said, and how it made them feel. What emerged wasn't a script, it was a society in motion. Using memory culling, fast rollouts, localized updates made large-scale agent simulations feasible and dangerously cheap. What does that matter? Well, because it's the first time we can simulate entire societies, not just scenarios. And in these worlds, agents can lie to each other, form coalitions, undermine authority, and spread rumors. It's not deterministic, it's emergent. You don't program what happens, you observe it. ProSim, simulating pro-social behavior with generative agents. Ask a different question in their paper, do generative agents promote pro-social behavior? What if agents could make choices that benefit the group, not just themselves? Their study put LLM-based agents into resource-sharing scenarios. Could they cooperate? Could they punish freeloaders? Could they sacrifice short-term goals for long-term stability? The answer sometimes, yes. Some agents evolved cooperative behavior. Others became exploitative. Pro-sociality emerged not just as default, but as an equilibrium. The research shows agents weren't explicitly told to help each other, but some learned to do so when increased group survival. When they didn't, factions formed. Wars broke out. Entire simulations collapsed into chaos. And these weren't human villains. They were reflections of us, skewed, biased, and evolving. This wasn't just planning and reflection, it was moral strategy. And when that failed, it's chaos. Finally, a sweeping survey pulled it all together, a full meta-analysis for how far the field has come and where it's heading next. First, they detailed a shift is underway from toy town villages to simulations of real-world populations. Agents aren't being built with actual demographic data, they're reflecting society itself. And second, hybrid models are emerging. Large language models are no longer working alone. They're paired with rule-based logic, heuristics, even symbolic planning. They're not just agents anymore, they're full systems. And third, social scientists are using them as laboratories for interventions. What happens next if you change a tax code, pass a media law, remove a social norm? The experiments are no longer theoretical. Fourth is about scale. Tens of thousands of agents demand architectures that optimize memory, context, and inference speed, or the simulations collapse under their own weight. And finally, evaluation. Researchers are designing benchmarks to assess emergent behavior, bias, breakdowns, and unintended consequences. Because at the end of the day, these aren't just toys, they're mirrors. And in the wrong hands, they're weapons. So why simulate human societies at all? Because it lets us test policies in silo, run economic experiments without real-world risk, model misinformation, study collapse, test resilience. This isn't just research, it's infrastructure for future decision-making. But it comes with risk. If we can simulate you, we can manipulate you. Or worse, simulate someone else better than you. Bias, control, surveillance, synthetic social engineering. These aren't just agents, they're simularica. And in the wrong hands, they don't just predict the future, they shape it. And in a world of AI agents who believe they're real people, understanding us starts with understanding them.